engage some people using it. So what are all the little things that we oftentimes forget when we're doing that, that'll get us from a local development box to running on the internet that people can access? And I think you've all started using Heroku a little bit, is that correct? Cool, so some of this will look real familiar. At any point, please feel free to stop me, ask a question if I use a word that you don't know what it is, or if I have something wrong, because you've worked on Heroku more recently than I have, please let me know. But feel free to chime in at any point. Okay, so who am I? Well, John Gore is my name. I've done development, DevOps, project strategy, as well as a partner at TableXI for the last decade. I've also got a side hustle that's everyone on board. It's an app that connects people at a company for coffee chats, so you can get to know each other a little bit better. And I'm still learning every day, trying to pick up new frameworks, new technologies. So that's been quite a process. All right, so let's talk about the typical architecture when we talk about cloud hosting something. So when you're running your app on your laptop, it's really got four components. The first is the web server. When you type probably Rails S to start your Rails server, you're starting up either WebBrick or Puma or Unicorn, probably Puma if you're using the newest Rails, and that's your web server that's starting up. So that's how people can connect to port 80 or port 443, or in your case, localhost 888, probably 8, one more 8. And that's running your application. So this is your actual code, your application layer. And that's the main part of your app, but most of the time you're going to have a data store for your application. So do y'all use Postgres, MySQL? Postgres probably, yeah. So that's your data store. Of course, there's lots of them. You may have heard of Redis. Memcache is a type of data store. You know, if you want to make bad decisions in your life, it could be Oracle, you know, whatever floats your boat. And then finally, static files. And I'm counting these separately because we really think about two different kinds of static files. One might be files that you include in your repository and you're serving out of public. So for example, the logo that's on your homepage, something like that would be a type of static file. But what I'm referring to here is files that aren't in your repo. So imagine a user uploads an avatar or attaches a document to a note or something like that. Those would be the sort of static files that are outside of your repo, therefore they're sort of separate from the application. But those are the four main components when we think about, you know, starting a Rails server on your laptop and kicking off your code. So what does this look like on the cloud? Well, the first thing to remember is that there's not really a cloud, it's just somebody else's computer you're paying for. So everything else, you know, you learned about running on your laptop directly applies to running something in the cloud. It's just running on somebody else's computer that you're paying for on typically an hourly basis. So let's take a typical cloud setup. We've got, you know, a user on their phone over here on the left, and then we've got the main components, the data store, the web server, and the application, and the static files. And in a cloud setup, these are typically different computers. Of course, this varies. You could just buy, you know, one cloud-hosted server and throw everything on one. But if you're using Heroku, for example, your web server application is on one system, your data store maybe on one or other multiple systems, Postgres, and then your static files could be on an entirely different system. But so far, this is looking pretty familiar. But we realize that oftentimes when we're hosting something in production, we might be running multiple application servers for redundancy, you know, in case one of the boxes goes down, for reliability. So one server is not cutting anymore, I need to add multiple ones. And this presents, you know, if we've got 3 web servers, how do we route requests from one to the other? So that presents a problem. So there's typically a load balancer sitting in front of it. Very basic setup. So what happens? Well, a user makes a request. That actually hits the load balancer, which is one or multiple systems, that then says, well, you know, this web server is free, so let me route that request to here. That web server looks at your application code. Maybe your application code says, oh, I need to hit the database because they're calling an article, and I need to look at that article from the database. And then the database, your application maybe also says, oh, I need a static file to link to here as well. It's you know, an image somebody uploaded. That goes back to the application server and then gets routed back to the user, and the web page is delivered. Note also, we'll get into this a little bit more, but oftentimes static files can be served directly to the user. So think about the term CDN, Content Delivery Network. Oftentimes you'll be hosting a bunch of images, at one domain, like media.mydomain.com, and your applications at www.myapp or app.myapp or something like that. And in that case, the user is oftentimes talking directly with the static file store. Have you all used S3 yet? Amazon S3?
Yeah.
Great. So S3 is a case where you can either choose to have the application go pull the file off of S3, and then send it directly from your web server, or more often, you're just going to say to the user, hey, here's the file you need, and it's at this address at S3. And that would be a case where the user is downloading that file directly. So in Heroku, this looks very similar. It's the same basic setup, but Heroku does a great job of hiding a lot of this complexity from us. So we've got sort of the platform, Heroku's magic, and that's when you enter, here's my app, here's some information about it. One of the things they're doing is setting up the load balancer for you. And when they give you that CNAME, the endpoint to point to, it's randomword.herokuapp.com or whatever it is, that's actually a load balancer that's run by Heroku that you're hitting. And then the dynos, those are just your individual web and application servers. And so you can say, I want 10 dynos, I want 1 dyno, whatever is appropriate for your application. You've got the data store. I assume you're using Heroku Postgres. So that's running on its own server. And then static files, oftentimes you use S3 because Heroku doesn't have a great static file system on their own. Any questions about this so far? All right. So what does this look like at Amazon Web Services? Same basic setup, just different terminology, and a lot more configuration on your part. So for example, a load balancer, Amazon calls it the elastic load balancer. And instead of it just kind of magically happening in the background, you go in and create it and say what, do you want HTTP or do you want HTTPS? Where does it route to? Those sorts of things. And instead of dynos, you get whole servers, basically, EC2 instances, Elastic Cloud Computing instances. And now you're dealing with servers that are oftentimes running Linux, but it could be running whatever OS you want. AWS supports Windows and others. And you're going in and you're configuring those and saying, okay, use this web server. Here's my code, getting the code on the box. But same principle as the dynos, just a lot more hands-on. AWS has its own data store. They call it the Relational Database Service, and this is just a way to easily spin up a Postgres server, a MySQL server, Microsoft SQL, Oracle server, whatever you want, and stamp those out. And then finally, Amazon S3 again. So very similar to Heroku, just a little bit more involved. If you want to play with Amazon some more, I would encourage that. And they have a lot of other services that simplify this and make it closer to the Heroku experience. So this is sort of I want to do it all on my own AWS setup, but Amazon has just gobs of different services, things like Lightsail and their containerization system that make it easier and more Heroku-like experience. So this is really just the bare bones basics if you were to do everything from scratch on AWS. All right, so you're ready to host your app. Let's set up our Heroku or AWS account. This should look very familiar to you. Payment information may or may not be necessary depending on what you're running. Purchasing a domain, spin up your services. I want 2 dynos and I want it at this address. And then managing your domain name server. Have y'all done anything with DNS, or have you been running your apps from the name that Heroku gives you?
We've been using the name with that Heroku gives us.
Okay, great. So DNS is, stop me if I'm being too obvious here, but if I have that name from Heroku, but I want to host it at john.com, I would need to say, hey, point john.com to that Heroku service, so that any user on the internet can use john.com instead of whatever obscure Heroku app name I get. DNS is just a way to purchase john.com or whatever, and then manage those records of saying, www.john.com points here, myapp.john.com points somewhere else, etc. So it's really just managing, purchasing a domain that you want, and then managing it by associating it with wherever I'm hosting that service. So Heroku in your example. Purchasing domains, Hover's what I use, Network Solutions, GoDaddy. These should all sound familiar to you, if nothing else than GoDaddy's stupid Super Bowl commercials from a few years ago. All right, so you've got your account set up, and you've got DNS. You're done, right? You're online. No, not quite. Your app isn't uploaded. So you experience this with Heroku. You may have created your Heroku account, but now you have to get your code actually running there. And you've probably used the Heroku toolset. Did you use the web-based deployment or command line? Command line? Great. That's a great way to do it for Heroku. If you choose to deploy to somewhere like AWS or DreamHost or any kind of other provider that doesn't have a cool tool set like Heroku does, there's a great gem called Capistrano that you can add to your Rails project and then tell it things like, here's the server you should deploy to, here's the user you should log in as, here's the code repo that you should download onto that server. Have you used anything like Capistrano or just the Heroku tools? Cool. Great. So now you've got your software on there, your app, but it's not secure. So HTTPS, that's the secure web protocol. It's protected by SSL. It keeps things private. It's also SEO friendly. Google gives you a boost if you're running HTTPS, or rather they probably give you a negative if you're not, is the way they think about it. These days you get browser warnings, like the one on the right, if you're not using HTTPS. And it's super easy now and often free thanks to a company like Let's Encrypt, which provides free SSL certificates. Have y'all hosted anything at HTTPS or is it all HTTP?
HTTPS.
Great.
Well, Heroku does it automatically.
Yeah, they make it like the default now, which is really nice. That 2 years ago was a lot more difficult before Let's Encrypt came along. So you've experienced this then with making sure that all your internal links, once you update it, go to HTTPS and are either protocol relative or HTTPS leaks, so nothing new there. A problem you often encounter now that you've got it hosted in the cloud is that you can't send email. And that's because most cloud hosts restrict outbound email to prevent spammers from using their system, spinning up a box, sending a million emails and spinning it down. And even if your host doesn't do that, sometimes seeing that the emails come from a Heroku box or something like that can mark those emails as suspicious, and the people you're sending them to are more likely to have it flagged as spam. Have you done any apps with email sending yet? Cool. Well, once you do, there's a couple ways to get around this problem. One is to use the normal outgoing email server like your phone uses, or if you have a desktop web client, to send your email through. So Google Apps, Office 365, Zoho are all examples of just normal SMTP providers. Oftentimes, though, when we're doing an app, we want to use a dedicated email sending platform that gives us a lot of extras and nice to haves, like SendGrid or Amazon Simple Email Service. So something like SendGrid, you send your emails through it. They've got a great gem you can just plug in, and it works great with ActiveMail. And then you get all sorts of statistics from them. They'll say, oh, these emails were open, these weren't, these bounced back, these didn't. When you have a bounce back, what do you want to do with that? What is your open rate? Just all sorts of great data and analytics. You're dealing with larger amounts of email. Amazon SES, sort of a similar experience. Their dashboard's a little more basic, but still a great way to just drop in a gem and then send your email through those providers, and you avoid a lot of the complications that comes from trying to send email directly from your own application server. Your app can't send files. So you've got it up there, but you realize that your application servers, those are disposable. So a dyno could go up, a dyno could go down. And when it does, it oftentimes loses the local storage that has. So if you've uploaded a file and only stored in local storage and you restart your dynos, you could lose that file. So the next person who goes to download it isn't able to access it. In addition, if you have multiple servers and I upload a file to just one of them, then somebody tries to access that file and hits another server, they're unable to access it. So let's imagine this setup. I've got a cat pic on my phone that I want to upload to my server that's running on 2 dynos. I send my request to upload it, and it goes to Dyno B, just because the load balancer said that one was free. That's great. I've got my picture there now, but it's not on the other dyno. So if another user comes along and makes a request for that image, they have a 50-50 shot of getting a 404 on it. And that's why we use something like shared storage, a separate service that's persistent, that doesn't get deleted, something like S3, that it's always going to be there, and that can be accessed by all the servers. So we make sure that the files go there, and then when somebody requests it, they're either requesting it directly from the shared storage, or both the dynos know, oh, I need to look for this within S3 or whatever my shared storage is, and then serve it that way. And then finally, you can store files using active storage, using Carrier Wave on Amazon S3, which is probably something you're using now. Do you remember what you're using? Just active storage? Cool. Cool. Yep, and that's gotten a lot easier these days. A couple of years ago, it was more complicated to lay in S3 storage, but it's become part of core Rails, which is nice. All right, your app's secure. You can send emails, you can serve files. You're all done, presumably. Yeah, technically your app's running good, but there may be a few other things you want to think about. So maybe you're having style problems. Maybe your style sheets in JavaScript aren't loading. This is probably the most common problem that I encounter personally and that other developers I see encounter personally first time they take something to production. Remember that we use the asset pipeline to write the kind of code that we like writing. So newer flavors of JavaScript, SCSS instead of CSS. But that a lot of browsers can't read those newer languages, so that we need to convert them to older JavaScript that's more compatible or just standard CSS. And that's happening in Rails. It's the asset pipeline. In newer versions of Rails, you can also use Webpack that then plugs into the asset pipeline. In development mode, everything just sort of works. The assets are compiled on the fly. But once we get to production, it's not magic. It doesn't do it for us. It believes that we should pre-compile those assets and then serve them, pre-compile them when we do the deploy, and then serve them without doing on-fly compilation. So it's super easy to forget when we write our code to make sure that we're actually pre-compiling the assets in the Rails configuration. It compiles like application.js and application CSS by default. But if I create a new style like article.css, it's not going to know to pre-compile that necessarily. In addition, if I reference an image in my CSS, if I don't reference it using the Rails image tags helpers, it's not going to know once it's pre-compiled what the correct name is and where to find it. So now I've got my background on my page isn't loading. So remembering to use all those Rails tag helpers for images and other assets is super helpful to avoiding this problem. Your app's out there, but the error pages are pretty ugly. This is the default Rails 404 page, for example. Not the nicest thing you've ever seen. Your users are going to end up experiencing 500 and 404 errors, so it'd be really great to provide a helpful page that has your logo that says, hey, we couldn't find the page you're looking for. There's a server error, but here's some stuff you may want to try. So the goal here is just to rescue from errors that we think might happen and then show helpful error pages that we've customized. Any questions at all? All right. So your app's out there, but it's probably relying on a few third-party services. And when those are down, your app breaks. So have y'all interfaced with any APIs, other services, Stripe, or what are some examples? Perfect. So Twilio is a great example. I need to send a text message when this order is completed, let's say. Twilio API is down, somebody hits place order, and then they get a 500 page. They don't know if their order was placed successfully. They maybe hit refresh, which could cause problems. It's just a terrible user experience. So we should always trust that third-party services are unreliable and that there is going to be a point where they go down. So we should handle these service errors very gracefully. A great way to do that is to decouple that service call from a web request. So let's take the Twilio example. Somebody places an order. Instead of immediately on that request contacting Twilio and saying, hey, send this text message to this number, instead we add it to a background job that then wakes up and says, hey, have any orders been placed recently? Oh yeah, there's this one. Okay, I'm gonna send that to Twilio. And at that point, even if Twilio's down, it'll just keep retrying. And there's lots of tools to help you do that. Rails has built in active job, which is sort of a wrapper around the actual implementations of how to send queued work. So delayed jobs is a great gem for that, as well as Sidekick and Rescue. Those are sort of the three most popular that I use. Your app is not accessible or search engine friendly. So you built your app locally, you weren't really thinking about these things, that's fine, but now's the time to start to make use of things like page title meta tags. And I'm lumping in accessibility and search engine friendly here for a reason. A lot of the things we do to make our website look good to Google really helps people who are using screen readers, who are accessing a site in different ways or non-standard browsers. So things like a page title, being able to mouse over or tab through tabs in your browser, if you're a visually impaired person, have it actually call out something useful that says, oh, this is the site name and this is the page you're on, as opposed to, whatever, or having a blank, worst case scenario. And same with heading tags. So using H1s, H2s, H3s, that helps Google understand where your content is, but it's also a big help to people using screen readers and other accessible technologies because those look for things like the headings. Same with semantic HTML5 elements. So you've probably been using a lot of divs and things like that, but HTML5 also offers tags like section, summary, article, figure, that tell you not only that, hey, there's some sort of division here, but what it is. And that's super helpful for Google or for users relying on accessibility technologies to understand your content a lot better. Image alt tags. What is a description of the image that I'm looking at? If I am browsing on low bandwidth and maybe I have images disabled, it's super helpful to have text there that says, oh, this is the logo, or this is a diagram showing X, Y, or Z. Meta tags. Is anybody familiar with canonical meta tags? This is sort of my pet peeve, so I will give you a longer explanation of this. Think about your Heroku app. It's hosted at myapp.herokuapp.com. Imagine that you have a domain associated with it now. So now it's go with john.com again. Right now, that is potentially accessible at two different addresses, that same content. It's accessible via myherokuapp.com and it's accessible via john.com. Google looks at that and goes, oh, you've got duplicate content. I'm going to ding both of these sites because somebody copied from somebody, and I'm just going to ding them both. Canonical tags are a meta tag that you can put in your header that says, no matter what the URL is in the bar, no matter what the subdomain is, no matter whatever, this is the where this content originally lives. So if you think about, if I go to myapp/home, that's a valid URL. But so is probably in the Rails context, myapp/home/. Google looks at those as two different URLs with or without the slash. But if you've got a canonical tag that says, no, this is always, /home, and it doesn't matter what they put after that, that's where the SEO should go to. That's super important. And like I said, in the cloud hosting, where we've oftentimes hosted things at multiple domains, whether we realize it or not, and where our frameworks allow you to get to content any number of ways, it's super helpful to have those canonical tags in there that on every page says, this is what the URL really is. And finally, logical URLs. So naming your page something that's useful. So checkout instead of CHK, something like that. Something where if a user glances at it, they understand what it is, and something where if Google looks at it, they say, oh, this is a product page, I can glean that from the URL. And it also potentially gives you keywords as well that Google could attribute to if you use them in the URL. Be sure you generate a sitemap, and there's a lot of gems to help with this, and verify it. Google's got a tool called the Google Search Console, where you can just upload a sitemap, they'll look at it and go, oh yeah, that's the right format, you've included everything here, you're good to go. It's really easy to make mistakes on sitemaps, so running it through something like the Google Search Console is very helpful. And finally, meta tag everything. Facebook and other groups have come up with ways to label content on your web pages that help them classify it even more than semantic HTML5 and things like that. So let's say I'm on Twitter and I want to share a URL. It is the meta tags within that page, the things like Open Graph that tell Twitter, here's the 3 sentences you should use as a summary, here's the image you should use, here's the title you should use, and here's the canonical link, and here's the author. So on Twitter, you may see these nice little cards when somebody posts a link of well formatted with the image and the title and all that. That's because people have, the people who created that site did a good job of making sure that they tagged all those things. And Open Graph is the biggie. Google has their own called Google Rich Snippets, but Open Graph is used by all the social networks and things like that, and also are signal indicators for Google as well. This is obviously more important on, some of these things aren't going to apply as much to a internal application, right? Like I've got a B2B application, I'm maybe doing HubSpot or something like that. These things matter more on the marketing side than they do on the internal guts of the application. I'm not going to be sharing, a dashboard page that's only accessible via password for my company on Twitter, for example. And I don't care about SEO on that anyway, other than just making sure that Google doesn't ever see it in the first place. All right, your app, you've got it out there, but it's a little bit of a black box. It's running, but are you tracking traffic and events that are happening on the site? Like somebody used a contact form or somebody reset their password or logged in. So using Google Analytics to give you high-level traffic data and event data is super helpful. And there's just the nuts and bolts of hosting something that's live on the internet. Do you know when it's up? Because that's super important. Nothing's worse than 3 days later, having a customer email you and say, hey, I haven't been able to access your site, and you realize you've been down for 3 days. So using something like Pingdom, StatusCake, Uptime Robot, there's a lot of these services that you just enter your URL, and they'll monitor it every couple of minutes and send you an email or a text message if it's down. Your app is probably throwing some errors, whether you realize it or not. So using a service like New Relic, Rollbar, there's a gem called Exception Notifier that works as well to let you know when errors occur is super helpful. For your normal use case, you're interacting with the app, you might not see any errors, but I guarantee you there's all sorts of bots, spiders, intrusion detection systems that are going to be hitting your site all the time with funky URLs, with funky request headers, and those things are generating errors all the time. So for you to monitor those and then try and figure out how can I minimize these sorts of errors is super helpful. And something like New Relic, for example, is their free plan is included with Heroku, so it's an easy thing to add into Heroku. Have you all played with any of that stuff yet in Heroku? Any of the plugins? Cool. New Relic's pretty great, and it's free with Heroku, so that's nice. And finally, you probably want to monitor performance. Is my site slow? Is it fast? Are users having a bad experience? And New Relic has the ability to do that, as well as there's another tool called Skylight, which is great. And even Google Analytics includes some super basic information about just the time it took for the client to load. But it doesn't give you granular data like, the database request was really fast, but the page rendering was really slow. It will just give you a high-level total time. And that brings us to your app is slow. And this, I believe, is last, and for good reason. It's very common for the first thing you want to tackle to be performance, but you're oftentimes not going to encounter many performance issues in modern frameworks if you're just sort of following the rules. But how can we confirm that? Well, there's the Google Page Speed Test and Web Page Test, which will find just problems with the way you've structured your HTML and your code. So for example, you're loading a ton of Google fonts up front and you're not doing it asynchronously. So we've got to wait for all those Google fonts to load before your page renders. Or maybe you've got some super large hero image that you forgot to compress and it's actually 4 megs where it should be 40K. So using tools like this where you just enter, hey, here's the URL and they give you a report back are super helpful. But if it's outside of that, let's say your database is slow, you use something like Skylight and it tells you that DB requests are slow, make sure that you're using the proper indices on your tables. Have you done anything with indexes in database tables yet? So think about a DB table that you create. It's going to have typically your ID column that's your primary reference. So I could look something up by ID. I could say, give me row 12, with ID 12. But oftentimes I'm looking up based on the URL for something, right? Instead of saying, give me ID 12, I say, give me the page with the URL my-article. And I would probably have that as a field in my database table that is what's the URL slug. Well, by default, there's not a index on that. So there's not an easy table of contents to go, oh, where's my dash article. So instead, Postgres is going to have to go through and look at every one in turn. Does this row have it? No. Does the next row have it? No. Does the next row have it? Yes. And then return that. But indices are a way that the, like building a table of contents or a glossary, index, just like in a book, where I can just look quickly alphabetically, go, oh, my dash article, that's row 14, something like that. So it's very easy to forget. We get so used to, as long as I look at by ID, everything's fast. But once you've got a table with 10,000, 100,000, a million, 2 million rows, if you start looking up by something that doesn't have an index associated with it, it's going to get real slow, real fast. So just think about anytime I do a select from a table, oh, does that have an index on it or not? Also avoid n+1 queries. Does that make sense, n+1? All right. So your typical query, if I say find this article with this ID, I just need to do one request. But imagine that I were loading a list of users. So I'm selecting all the users from the user table, all their email addresses. And then let's say their avatar picture is in a different table. So I do one query that is find me all of the users. That's easy. That's just one query. But now I iterate over each one of those users and say, okay, what's John's avatar image? What's Jane's avatar image? What's Paul's avatar image? And now for each user, I'm doing an additional query. So that's sort of the n+1 query problem of, for every one I load, I have to do more queries. And think about how, if you've got lots of tables, that can get really ugly really quick. So Rails includes things like the include as part of our query. So I can say, in this one query, get me all the users of this table, and then go ahead and include the avatar image table for each of those as well. And then I'm only doing a single query. The response I get back from the database is a lot larger because it's including all of that info. But it's a lot better to do that, typically, than to have just tons of tiny little requests back and forth. There's gems like the bullet gem that do a pretty good job of helping identify where you maybe have these. You load a page, and it'll come up and say, oh, it looks like you've got these ugly queries that you could simplify. Your app might need caching, but it probably doesn't. So you've got client caching. So when we go to a web page, our browser typically caches the images and the CSS file and the JavaScript and things like that. But there's also server-side caching. So the idea is that if I request a page, the server has to do a lot of work to build that page. It has to look at your code. It has to decide, okay, I need to pull these 3 things from the database, and then I need to render it, and then I need to include this file and do all that work. We can do server-side caching, where it basically snapshots that page. And so the next time somebody requests it, it says, here's the page already done. I don't have to do any database queries or anything like that. That's great, super great. You've got a really, really high traffic site. But the vast majority of work you do, you probably won't need that. And it gets complex quickly when we start to talk about caching. Because imagine I'm a logged in user. Well, my experience going to this URL may be different than your experience going to this URL. So the basic example, I'm on Amazon. My homepage is totally different based on the user I am. But even something as small as in the top right, welcome, John, the message of who you're logged in as is going to be different. So if I cache, when I'm logged in and somebody else comes, we don't want them to see welcome, John. We want them to see welcome, whatever their account is. So there's great tools in Rails to sort all this out, but it's not straightforward, and it should sort of be a last result when you think about needing caching. Most of the time it's due to something like missing database indices or ugly queries or things like that that are really your problem, and caching should kind of be sort of a last resort. And finally, you may need more server horsepower, but probably not. This goes back to, once again, like, what is your scale really at? Like, it totally is dependent on the Rails app, but if you're talking about, tens of requests a second, that's nothing on most systems. Once you start talking about hundreds, thousands, tens of thousands of requests, then we're talking about, oh, you may need more dynos, you may need larger servers, you may need more RAM, but typically you want to make sure you've exhausted the other optimization options before throwing hardware at it, because that's the equivalent of money. All right, so you fixed everything. Are you done? Uh, yeah, but invariably you forgot your favorite icon, which everybody always forgets until the last moment. So you're going to want to take care of that. But otherwise, yeah, I think that's good enough. You've got your live production ready app and you're good to go. That's all I got.
Thanks so much.
Thank you.
Any questions?
Also related to anything software related, because John hired more people than everyone here has experience.
In the beginning, you talked about your road to learning other libraries and languages
Mhm.
and stuff like that. Could you expound on that and how your experience has been, what you've been learning, how you've been learning it, stuff like that?
Yeah.
What made you decide to learn what?
Yeah.
Sure. I, went to school for software engineering and learned, a lot of languages there. They give you a little bit of a bunch of languages, and none of it really sticks all that well. But mainly Java was what I worked in the most. And then my first role at TableXI, we were using Perl. And so sort of what I learned next was dictated by the job. And there, I followed the same framework I've learned with everything else, where it's like, for me, my personal way, I don't pick it up from reading a book. Like I can glance through a book, but it just doesn't stick for me. It's solving a problem. So in the context of, if you're working in an organization, it's typically what is the smallest task, the smallest change that is needed on this website or on this property. So it's, change this copy on this page to something else. Or, we're showing first name when we should be showing last name, on this page, something like that. And it's starting, for me, it's definitely by doing. I've also found that working in a vacuum doesn't work well for me. So have you been doing any pull requests and pull reviews with this group? Code reviews of each other's code?
No, not that.
All right. So super helpful. So once you get out into, I hesitate to use the term the real world, but, in a software job, typically you're going to have other people who can review your code and you can review theirs. So they can look and go, this is one solution, but it's not very efficient. Have you thought about doing X or Y instead? Or they can look, in the case of a more experienced engineer who knows the platform, go, this is a great solution, but you forgot about how this is going to impact this whole other section of the app because this is shared code between them. So working with other people and reviewing code is super helpful. And a tool that I use to do that myself when learning new frameworks in my spare time is exorcism.io. Are you all familiar with that at all? Great. So I love that. I pick it up, do 3 or 4 exercises. And then what helps me more than doing those exercises myself are reviewing other people's exercises and providing feedback. So I try to do that. I might go a couple months without doing it, but then I'll do like 5 or 6 exercises in a day and then do 5 or 6 the next day and that sort of thing. So tools like that now have been really helpful. And once again, there for me, it's not the reading about it, it's the doing. And it's about having somebody else review my code and then me reviewing other people's code. That's been super helpful. In terms of where I'm going next and decide what to learn next, I'm pretty conservative when it comes to technology. I'm not a bleeding edge. I want to use the new hotness. I'm not itching to do blockchain. I did not get on the NoSQL bandwagon when that was around. But once something, once you're on Stack Overflow and you see enough questions about it, once you start looking at GitHub repos and see that more and more people are using the technology, that's when I sort of pick it up and go, okay, I should play with this a little bit, build just a notepad app or something basic in it. So I'm doing that with React right now, which I'm obviously very slow to the React party because I've been busy working on my other side hustle. But just trying to do that where there's enough momentum, everybody's talking about it. You've got other knock-on benefits like React Native and other similar frameworks that are helpful where I go, okay, I should know about this and at least understand the architecture and how to implement it a little bit. Does that answer your questions at all? Any other questions?
Basically, like any knowledge you would like to share, like stuff that I guess you have picked up along the way that you think of like it's really important, whatever it may be.
I mean, this is such a basic thing, but the biggest challenge I see as more junior engineers work is know when to ask questions. Especially once you get out, working with a team. there's no shame in asking questions at all. And if there is, then you're working at the wrong place and you shouldn't be there, because that's how we all learn, is by asking questions. But understanding that, let me plug away at this for an hour. Let me see if I can sort of suss this out and figure it out, at least so that when you come to ask the question, you have a basic understanding and a basic knowledge of what you've tried, the scope of effort you've looked at, and then you probably have a thought like, I've been trying it this way and that seems really more difficult than it should be. Is there another alternative? And then we say, oh yeah, it is more difficult because you didn't think about using this or using that tool that this language or framework affords us. But doing sort of that little bit of basic work, then not being so committed to go, I'm going to spend 2 days trying to figure out this basic thing, and I'm going to be stubborn and not ask the question. Because then somebody goes, hey, where's that thing you were supposed to deliver? You go, I'm stuck on it. And they go, why didn't you ask me 2 days ago? So it's finding that balance between giving it an effort, making sure you sort of understand the scope of what you've tried and the problem space, but then being totally willing to ask for feedback and questions. And that's such an art form when you're just starting out. It's really difficult to perfect, but that will help you move forward a lot faster. It's just knowing when to ask questions.
Going off of that, what differentiates somebody that you hire who's very junior between that, like somebody who is hired by you or somebody who's not hired?
On the junior side, there's the basic competency, right? Like, can you do this code kata, this simple exercise? For all of our hires, we try to have them do the real work. So what that means is, for a project manager, we actually have here's a project. I'm going to pretend to be a client. Let's walk through spinning up this project, and then you tell me how you manage budget and things like that. For developers, we actually have a project that we pair program on. So it's a code base. And we say, hey, let's work on this together. And what really differentiates a good junior there is, do they have just a basic understanding of code, right? That's sort of the bare minimum. But then how do they engage? Do they ask questions? And it really goes back to that, can this person collaborate? Do they know when to ask questions? Do they just stare at the screen for 30 minutes, which I've seen before? And so you kind of want to prompt, you want to be like, hey, if you're stuck, that's cool. Let's just talk this out. But then they type a word and then they backspace, and they type a word and then they backspace. So really, for us, for TableXI, it's how can you work with others? Once you've got the basic, I can write a loop, I can do that stuff. It really becomes, how do you learn and how do you work and collaborate? And we try to get at that through the pair programming exercise. You're not going to have that opportunity in a lot of interviews. A lot of interviews, they may throw FizzBuzz up on the board, sort of the classic programming test challenge. And that's going to be the only sort of programming technical aspect that they have. So if you're able to ask good questions throughout the interview process, I would plan on, if you can spend 25% of your time in an interview asking questions and having them talk, that's going to be a lot better than you having to do 95% of the talking. It shows you're engaged. It shows you have interesting questions to ask. Having follow-up questions like, what technology do you work on? What stack do you use? That's great. But then knowing to follow it up with, why did you choose that? What have been some of the problems you've had with it? What have been some of those successes? Are you looking at trying something new in the future? Those sorts of questions show that you're the kind of person who's able to think through a situation on your feet, and not just, parrot back, some memorized exercise or something that But like I said, if you have an opportunity to pair a program in an interview and you can exhibit that, great. But you can also do that just in the normal interview process by asking insightful questions. And it's something you can absolutely think through the interview beforehand, especially after you've been in one or two of them. They're probably going to ask you something technical. They're probably going to ask me, what's my greatest failure and my greatest, success, questions like that. So pre-game it, think about it, and then use that opportunity to show that you're inquisitive and engaged.
Anybody else? Thanks, John. Appreciate your time.
My pleasure. And